Hello, and welcome back. We have been on quite a journey together through this series. For this final explainer, I really want to just take a step back. We're going to move beyond the specific algorithms and tools we've been talking about and get into something, something more fundamental, something that actually lasts. So let's dive in. What is engineering wisdom, really?
If you think back to when we started, it was all about building up our toolkit, wasn't it? We covered the absolute foundations, algorithms, data structures. From there, we learned how to optimize systems using things like graphs and scheduling. And then we got into the messy, real-world stuff, reliability, cost, and that all-important layer of ethics. We're really focused on the what and the how.
But somewhere on that path, something subtle but really profound starts to happen for every engineer. The focus shifts away from just collecting skills and moves toward applying judgment. So this final conversation isn't about adding one more tool to your belt. It's about facing the incredible responsibility of deciding how to build. And maybe even more importantly, knowing when the wisest choice is not to build at all.
So here's how we're going to break this down. First, we'll try to define the nature of this wisdom. Then we'll look back at the arc of the journey we've just been on. We'll explore that big shift from looking for simple answers to navigating complex trade-offs. We'll talk about the character of wisdom, feel the true weight of our work, and finally land on what's called the quiet standard.
All right, let's jump right in with our first section, the nature of wisdom. The core idea here, really, is that it's a huge shift from knowledge to judgment.
I love how this slide just cuts right to the chase by showing us what wisdom isn't. On one side, you've got the common traps, thinking it's about memorizing design patterns, knowing the absolute fastest algorithm, or always using the shiny new framework. Now, those are useful skills for sure, but they aren't wisdom. The real deal on the other side is this. Engineering wisdom is judgment under constraint. It's about making the best call you can when things are messy and imperfect.
So when does this kind of judgment really matter? Well, it becomes absolutely critical when your information is incomplete, which, let's be real, is pretty much all the time. It's essential when you are staring down unavoidable trade-offs, where there's no perfect choice. And it's most important when your decisions have consequences that ripple out way beyond the code, impacting users, society, and the world. That's where the real work of an engineer truly begins.
Now, this idea of judgment, it builds on everything we've learned so far. So for our second section, let's take a look back at the path we've traveled, not as a checklist of topics, but as a real journey of growth.
Think about the arc of this whole series as layers of growth. We started at the bedrock, structure, data and algorithms. Then we built on top of that with optimization, making things run better with graphs and scheduling. But then reality always hits, right? We had to face failure, things like deadlocks, outages, and recovery. That forced us into the next layer of messy reality, dealing with cost, production, and unpredictable humans. And that finally brought us to the highest layer, responsibility, where we have to think about ethics, alignment, and our impact on society.
And here is the absolute key insight. Engineering isn't some straight line where you just add more and more skills. It's layered. And each new layer you add actually constrains everything beneath it. Your understanding of ethics changes how you think about optimization. Your experience with failure completely changes how you design your basic structures. It is a really profound shift in how you see the world.
And this brings us to our third section. See, as you move up through these layers, the very questions you ask start to change. You stop searching for perfect answers, and you start learning how to navigate necessary trade-offs.
I think we can all relate to this, right? Early in your career, the question is simple. What is the optimal solution? It's a great starting point, but it's incomplete. The experienced engineer, the wise engineer, asks a much richer set of questions. Optimal for what? Optimal for whom? And for how long? Suddenly, context becomes everything, and the definition of best gets a whole lot fuzzier.
And this slide, man, this is the daily reality we live in. Every single important decision is a balancing act. Are you trading raw performance for better reliability? Are you sacrificing speed of development for code that's easier to understand? Are you giving up some automation to keep a human in control? Or trading the efficiency of scale for a deeper human understanding? These aren't problems you solve. They are tensions you manage constantly.
And that leads to this incredibly sharp and powerful conclusion. Since every choice has a downside, wisdom isn't about finding some magical solution where you lose nothing. Wisdom is about consciously and deliberately choosing which loss you are willing to accept in order to achieve something more important.
So what builds this ability to choose well? That brings us to our fourth section, the character of wisdom. This is all about the personal qualities, the hard-won lessons that you can only get from experience. You know, experience teaches you some really surprising, counterintuitive truths. You learn that most catastrophic failures are not actually technical problems, they're communication problems. You find out that most big outages aren't caused by one obvious bug, but by a chain reaction of small things. You realize, painfully, that most of the harm caused by technology is unintended, a side effect of assumptions we never questioned. And you learn that most systems show signs of failing slowly, long before they fail loudly.
And this is such a critical point. It is almost never a lack of knowledge that brings a complex system down. It's the things we were so sure about, the foundational beliefs we never even thought to question. That's what becomes the source of the collapse. Wisdom, then, is the discipline of constantly poking at your own assumptions.
So if wisdom is about questioning your assumptions, then its practical application is humility. Wise engineers, they design for failure. They expect their documentation to be misunderstood. They assume their system will be misused in ways they never imagined. This humility isn't just a feeling. It's a concrete engineering practice. It shows up as observationality, so you can actually see what's going on. It's reversibility, so you have an undo button. It's guardrails and human-in-the-loop designs. And here's the key takeaway. Confidence is what lets you build the system in the first place, but it's humility that actually keeps it alive.
This idea of humility becomes even more critical when we consider our fifth section, the true weight of our work. Because as engineers, our decisions have incredible leverage, especially when we work at scale. See, as your systems scale, your decisions just propagate far beyond what you ever intended. Tiny errors multiply into massive problems, small design defaults slowly harden into society-wide norms. This is why engineering wisdom demands that we ask what might be the most important question of all. If this system is wildly successful, what kind of world does it help create? We have to remember, not everything that can scale should scale.
This sense of responsibility also forces us to face the temptation of just being clever. We've all seen these clever systems. They're impressive, right? They use complicated algorithms, non-obvious tricks. They definitely impress other engineers. But they also confuse the people who have to operate them. They break in silent, unpredictable ways, and they age terribly. Wise systems, on the other hand, well, they're often kind of boring. They are predictable, they're understandable. They are the kind of system you can actually explain to someone over the phone at 3 a.m. during an emergency.
And that's really the enduring truth here. In the long run, a system that is clear, simple, and maintainable will always be more valuable and more resilient than one that is just clever. Clarity simply has a much longer shelf life.
And that brings us to our final section, the quiet standard. After all the frameworks have changed and all the programming languages have been replaced, what is it that actually remains?
Years from now, I promise you, you'll forget the specific syntax of a language. The APIs you mastered will be gone. The tools you use today will be obsolete. All of that technical detail, it fades. But what remains? What's left is how you reasoned when you were under pressure, how you balanced those impossible trade-offs, how you treated the people who used your systems, how you handled failure, both in the code and in yourself, and how responsibly you used the power you were given. That is engineering wisdom. That is your real legacy.
Because in the end, engineering isn't just about solving problems, it is decision-making at scale. And those decisions go on to shape systems, and those systems go on to shape lives. So the highest achievement, the ultimate goal, is not to build the fastest or the biggest or the most powerful system. It is to build systems that are humane, that are responsible, that are just. Systems that, when you look at the world they help create, you can say with confidence that they deserve to exist. That is the standard. Thank you so much for joining me on this journey.